and they laugh at me. Okay, so we want. That's what I said. I said, man, like we use Google everything. You can't hook me up. Cotangent of this is 30 degrees, right? Okay, so cotangent of 30 degrees would mean that you look at 30 degrees on your unit circle, take your x value divided by your y value. If you go to 30 degrees, the x value is root 3 over 2, and the y value is 1/2. Sorry, I got that backwards. The x value is root 3 over 2. The y value is 1/2. When I have a fraction divided by a fraction, I don't like writing it as a big fraction. I like to write it like this, x divided by y. That's how I prefer to write it. To me, it's just like more visually understandable. Yeah, that's what we'll go with. Yeah.
Can I have a blank unit circle?
Yeah, I'll hook you up with one. Okay, now that we all got our unit circle. So if you look at 30 degrees, the x value at 30 degrees is root 3 over 2, divided by the y value at 30 degrees, which is 1 over 2. If you want to write it as a big fraction, like you're more than welcome to. I just think that's easier to understand. And then it's also easier for me to calculate because I know that I can kiss and flip that. So it's root 3 over 2 times 2 over 1. That means that cotangent of 30 degrees is just root 3. Right? The 2's would cancel out. 1, 2 on the top, 1, 2 on the bottom. Cotangent 30 degrees is root 3. That's, I think, the easier way to tackle cotangent ones. Cool. Tangent and cotangent of 45 degrees are both very easy to calculate. The reason they're easy to calculate is because at 45 degrees, x and y are the same value. They're both root 2 over 2. So when I do cotangent of 45 degrees, it equals x, which is root 2 over 2, divided by y, which is root 2 over 2. Anything divided by itself is 1. So cotangent at 45 degrees is 1. Only thing you need to be careful with things that end up on 45 degrees, whether you're quadrant 1, 2, 3, 4, is that you have the negatives right. All right, so if you switch quadrants, then you might have a negative divided by a positive or something like that. And our last one, cotangent of 60 degrees. Again, we know cotangent is x divided by y. So this would be 1 over 2 divided by root 3 over 2. Kiss and flip. This means that cotangent at 60 degrees is 1 over 2 times 2 over root 3. Again, those 2's will cancel. So the cotangent of 60 degrees is 1 over root 3. Which is correct, but mathematically not like proper because you can't have a radical on the bottom. So we rationalize our denominator. We multiply the bottom by root 3. What you do to the bottom, you do to the top. That gives us the cotangent of 60 degrees equals 1 times root 3 on the top. Root 3 times root 3 is root 9, which is just 3. So the cotangent 60 degrees is root 3 over 3. Yep.
Why wouldn't you just like flip it to be like a negative fraction?
Flip what, sorry?
Like to get something on the bottom to go to the top, to make it negative. Why wouldn't you do that?
That's exponents. Yeah. You're thinking negative exponent laws. So if I made a negative exponent, it moves out. Bueno. Okay. Let's look at some questions here before we're done. Evaluate the exact value of each of the following. Exact value is a sign that you probably should look at your unit circle. in Math 20-1, our questions always said, use your unit circle to determine the exact value. That's not going to be there anymore. Now it's just going to say evaluate or determine the exact value. And you have to know, oh, I should look at my unit circle. Perfect. Looking at this, cosecant. What's cosecant the opposite of? It's the opposite of sine. So what we're going to do is we're going to figure out what sine is at pi over 4 and then reciprocate it. Sine at pi over 4 is the y value at pi over 4, which is root 2 over 2. If we reciprocate that, it would be 2 over root 2. That means the answer for cosecant at pi over 4 is 2 over root 2. Correct. So that mathematically is right, but if it was a multiple choice test, that wouldn't show up, right? That wouldn't be one of the options. If it was written response, that would get you a lot of marks, but not all the marks. The reason why is you can't have a radical on the bottom, so you multiply the top and the bottom by root 2. That gives you an answer of 2 root 2 over 2. That can be reduced further. So I have a 2 on the top, a 2 on the bottom. Both are coefficients, so I can divide them. My answer is root 2. Do you feel like we remember that from yesterday? Yeah, not too mind-blowing. Should be review. Okay. Secant negative 5 pi over 4. What does negative mean? Yeah, it means you're going clockwise. So you're going the opposite direction, 5 pi over 4. There's different ways that you can tackle this. I would look at where positive 5 pi over 4 is, and then go that same distance the opposite direction. That's how I like to do it. If you struggle with that, like visually figuring out where it goes, you can always turn a negative 1 positive by adding 2 pi to it. So if you did negative 5 pi over 4, and you added 2 pi, which is just 8 pi over 4. Right? Have to get a common denominator. That will give you an equivalent angle. It's like going to the same spot. I shouldn't say equivalent angle. It's a coterminal angle. It gets you to the same location, which is 3 pi over 4. Whatever strategy works for you, do it. This might be a little slower, but as long as you're getting to the right spot, you should be good. Yep.
If you're doing it visually, why wouldn't you go the other way if it's backwards?
Yeah, so for me, how if I look back at my unit circle here, in my mind, 5 pi over 4 is here. So I would be like, okay, it took me 1, 2, 3 quadrants over here, and then I would do that backwards. So 1, 2, 3 quadrants. It must be this one.
Oh, okay.
That's how I visualize it.
That being said, can you just take the positive angle and reflect it? So 225, if you were to flip it up, it would be 135. 225.
How do you know to flip it up though? Because if you know that backwards, that's where it's going.
Well, if it were to go backwards, if it takes that much there, it's got to take that much the other way. So then it just
Yeah. So if that works in your mind, for sure, it's just flipping it the other direction, 100%. Yeah. That's okay, as long as you feel confident being able to get to the right spot with a negative angle. Do you feel like that's what? Yeah. Yeah. We okay with finding the positive angle? Like where this is going? Because those negative ones are tricky, right? Okay, so I know I'm in quadrant 2. Secant is the opposite of, come on, computer. What's secant the opposite of?
Cos.
Yeah, it's the reciprocal of cos. So you need to find cos at that point. Cos means x value. So you want to find the x value of negative 5 pi over 4. The x value of negative 5 pi over 4 is negative root 2 over 2. Then you reciprocate it so it becomes the secant value. Here we go. So I'm going to look up cos negative 5 pi over 4. That's the x value at negative 5 pi over 4, which is negative root 2 over 2. If you want that to become secant, then you will switch it to be negative 2 over root 2. You can just leave the negative on the top. All right, negatives float to the top. That means my answer is secant negative 5 pi over 4 equals negative 2 over root 2. We're going to have to rationalize that. So we multiply the top and the bottom by root 2. That gives you negative 2 root 2 over 2. We can reduce it. That is just negative root 2.
Oh, we can get rid of the 2's even though they don't want to divide it.
Yep, because the 2 and the 2 can both divide by 2. Why is it negative? It's negative because of where we ended up on our unit circle. So we would have gone to 3 pi over 4, right? Which is in quadrant 2. And I'm looking at x values in quadrant 2. All my x values are negative over there. So I know it's going to be negative root 2 over 2.
Wait, so it's not undefined if there's a negative for a root?
No.
It's not a real number though.
If it was a negative inside the root, it's not a real number. Yeah.
But I thought you had to go like 2 or if I'm going this way. I mean, just under 1. Oh, if it's from here.
Yeah. Of course. Okay. Cotangent, I like to just remember as x over y. I don't actually go through the whole process of figuring out tangent and then reciprocating it. That's too much work. Cotangent's easier to just remember a flip tangent. So instead of y over x, it's x over y. Looking at your unit circle, look for 3 pi over 2. 3 pi over 2 is on your unit circle. So that would mean like 3 halves. So if you're thinking about a unit circle, this is pi over 2. This is pi. This is 3 pi over 2. Down here. That point is at 0, comma, negative 1. The reason I know it's negative 1 is because the radius on my unit circle is 1. So if I went straight down from the origin, that's a distance of 1. I feel like that blew some minds. Everything's based off of knowing that this is pi. Right? So if you cut it in half, this is half of a pi. I want to get to 3 halves of pi. So 1 half, 2 half, 3 halves of pi. This point, I never moved left or right, so the x value is 0. And the y value is negative 1 because the distance from the middle to the edge is 1. So if I went straight down, it's going to be negative 1. Perfect. You want x divided by y. X is 0. Y is negative 1. 0 divided by negative 1 is 0. Cotangent at 3 pi over 2 is 0. Mm-hmm.
So if you had the cotangent of like pi or of 2 pi, then would you like, because then it would be not really.
I think
When you be dividing.
it does not. So if you had cotangent of pi, cotangent of pi would be this point over here. The x value is negative 1. The y value is 0, meaning I would have negative 1 divided by 0. You cannot do that. Can't divide by 0. So that means this is undefined. You cannot divide by 0. So if you ever do run into that, and you will run into that in your practice booklet, dividing by 0 causes it to be undefined. Typically, you're going to run into it with tangents and cotangents because you're dividing by x's and y's. You can also run into it with cosecants and secants because, again, you're dividing by x's and y's. All right, last one.
So for C, isn't it dividing 0 by 0?
Yeah, and that's okay. You can have 0 divided by something. You can't have something divided by 0. Subtle difference. Okay, last one down here. It's the hard one. So you're looking for cotangent of pi, 5 pi over 6, plus secant of 4 pi over 3. You break that down. This one will be x divided by y at 5 pi over 6. Then we're going to add this one, which is the reciprocal of what? The reciprocal of cos. So you need to find the x value at that point and then reciprocate it. So you could write it as this, like 1 over cos, or whatever you want to write it as. You could write 1 over the x value. That would work as well. But as long as you understand you're reciprocating it. Let's start with the cotangent. So if I go to 5 pi over 6 on my unit circle, it is there. Should be in quadrant 2. You want to do x divided by y. The x value, I believe, is negative root 3 over 2. Divided by the y value, which is 1 over 2. Has someone looked at their unit circle and confirmed that?
Yep.
A little bit of OCD, just want to make sure. Plus secant, so we're looking for cos, which is the x value. The x value at 4 pi over 3, which I believe the x value at 4 pi over 3 is going to be, I think, Mr. Kennedy, you're going to be in quadrant 3, so it's going to be negative, and it's x value negative 1/2. Yeah, bueno. We want to reciprocate that, so it's negative 2 over 1. We okay with that statement that I have on the bottom? Cool. All right. Calculating that, because you want the exact value, so no putting it in your calculator. You got to simplify it yourself. The blue stuff, we kiss and flip. When you kiss and flip, the 2's will cancel out. The blue stuff is negative root 3. Kiss and flip, 2's cancel. Plus, the red stuff, nothing there but minus 2. So you just go minus 2. The answer is negative root 3 minus 2. That's the exact value. If they asked for a decimal, then you'd calculate it. You feeling all right? I think that's the last one, right? So we're going to be moving on. Is there one more? Oh, I lied. Good thing you're shaking your head at me. This is the last one. Okay, the unit circle is shown below with an angle of theta in standard position. Point P, which is K, 0.6, is on a terminal arm. You can see that in the picture. We haven't reviewed those definitions. We will in a second, but they're all 20-1 definitions. So terminal point, terminal arm. This is your terminal arm. Next from the middle out to a spot on the circle. That's called your terminal point. The diagram shows it all for you. So you really don't even need to know what those words mean, and you'd be good. Perfect. The value of K is the exact value of secant is. Let's start with the first question, the value of K. You need to find this value right here. Okay. You don't know what angle theta is. And you don't know 0.6. That's not on your unit circle anywhere, right? There's no y value of 0.6 on your unit circle. So you're not going to be able to use your unit circle on this question, even though it said right at the beginning, the unit circle is shown. Instead, you're going to use knowledge about your unit circle to solve this question. What do we know about unit circles? The radius is always 1. Always. And that's the key to all of this. When I see you guys do these questions on like tests or practice booklet, people always pull out their unit circle and start trying to figure out where it is. Because it says the unit circle. And we're like, oh yeah, it's got to be on here. It's not. That point is a random spot on the circle. The key is that you know the radius is 1. So when you look at your diagram, you actually know this distance right here is 1. You also know that this distance, 0.6, is your y value right there. And what they've asked you to find is k, which is really your x value, which is right there. This just comes down to Pythagorean theorem. A squared plus b squared equals c squared. Yeah, and you could even probably just look at the answer and figure it out.
It's all 0.8. It matters if it has a negative or a positive.
Really? That's funny. If it didn't, let's just calculate it quickly. So this would be c squared minus a squared equals b squared, which means it's 1 squared minus 0.6 squared equals b squared. If you calculate that, I think you get 0.64. Is that right? Equals b squared? Yeah?
Yes.
Oh. Square root both sides. And you get 0.8 equals b, which is what all the answers were. Thanks, Amelia. I'm kidding. Perfect. It is not 0.8. Why is it not 0.8? Yeah, because of where it is on your diagram, right? So Pythagorean theorem will tell you the distance that you went, but it won't tell you the direction that you went. Look at your question. You are clearly going left. So it's 0.8, but it's negative 0.8 because you went to the left. K is negative 0.8. That narrows down our options to B or A. Your next job is to figure out secant of theta. Secant is the reciprocal of what? The reciprocal of cos. Perfect. We're on the unit circle. So cos means x value. So our x value is negative 0.8. If you want to reciprocate that, that means it's 1 over negative 0.8, which you could put in your calculator in math bracket, and it would tell you what that value is for secant. So secant of theta should be negative 5 over 4. The answer is A. Yeah, man. Remember that trick that I just did of cos equals the x value only works on the unit circle. Because you will get questions that are not on unit circle, and then people try that trick and it doesn't work. It only works on the unit circle.
Will we do examples?
Yeah, so if that wasn't on the unit circle, it's not x, it's x divided by r, which is x divided by 1, right? So like, because it's a unit circle, we just ignore that divide by r all the time. You'll definitely see some in your practice booklet that are not on the unit circle. Not sure if we have any coming up. All right. Angles and standard position. You actually saw a lot of these slides last year, so we should be able to kind of rip through it. We're going to learn some definitions, things you're going to see in reading questions, right? You're going to be like, wait, what does that word mean? Look at this picture right here. You have a frozen computer. Yeah. They would have to tell you. Yeah. You'd have to tell you what R is. So if it was like, it's not on the circle, they would say you're on a circle with radius 3. And they would tell you.
To go 1 over the x value.
Yeah. There we go. Perfect. First things first, people see this word a lot and kind of get freaked out. Let's see if I can spell it right. Cartesian plane.
It's an E instead of
It's an A, not an I, right?
yes,
Yeah.
or a T.
Cart. Right. Cartesian.
Like, if you're spelling
Is that right?
yeah, it's like Asian with an E at the beginning. Oh.
There's no way.
I will put money on that.
That's such a
I know like sometimes.
I thought it was cart and then ISEAN. Somebody Googling this fast?
It is with an E.
It's right. Oh, said. No one should have questioned you, Em. That's our bad. You're going to get questions like, you're on a Cartesian plane, and people are like, what? And they don't know what that means. Cartesian plane means X, Y, right? So this is a Cartesian plane. X, Y. Perfect. Initial arm. The initial arm is where you start your measurements of angles. It's always the x-axis. So the initial arm is this thing right here. The positive x-axis. It's where you start all of your anger. It's where you start all of your angle. It does start your anger sometimes. It's where you start all of your angle measurements unless otherwise told. Okay, so you will start at the initial arm. Your terminal arm is where you're going to measure angles to. So in this case, my terminal arm is this thing sticking out right there. Initial, that's where I started. Terminal is where I've like rotated to and where it stops. Terminal stops. Have you ever heard the term like a train station or a train terminal? I always thought they were the same thing. Like a train terminal is the last station. That's where it stops. Yeah. So if you ever had a train terminal, that's where all the trains stop and would then go the other direction. Now you know. Terminate ends it. Angles in standard position, which is what we usually are measuring in. Standard position means that you went from the initial arm, the positive x-axis, and you went counterclockwise this direction. That means standard position. You've already seen that terminology in some of our questions, and I've been measuring everything this way because that is typically what we do. We talk about standard position angles. And it'll stop wherever the terminal arm is. Yeah. Co-terminal angles. So I have also used that term. It's an angle that'll get you to the same point. Right? And for instance, if you look at this thing right here, there's a few different ways you get co-terminal angles. Typically, when I talk about co-terminal angles, I talk about doing a full rotation first and then going to the terminal arm. So if I started at the initial arm and I did a full rotation, so I did a 360, and then I did the same distance as the standard position, I would get to the same point even though I'm a different angle. All right, this is a much bigger angle. It went 360 plus that distance. But it got me to the same terminal arm. So it's called a co-terminal angle. It would get you to the same spot. You could also go backwards, right? And we talked about when I was adding 2 pi, right? I was adding a spin. So I was taking negative angles and making them positive. That's because they're still co-terminal. Even if they go backwards, that's co-terminal, right? If I started here and I went backwards to there, that would be a co-terminal angle because it gets me to the same point. It just took a different route to get there. There are infinite co-terminal angles because I could just always do one more spin around, one more spin around, one more spin around. That means we have something called the general solution, which is actually at the bottom. So the general solution gives you all possible angles. So all angles. The way we calculate the general solution is we say, take your standard position angle, theta, and then you add 360 to whatever that angle is. That would be a full spin. And you do that as many times as you want, n times. This means take your standard position angle, do a 360, you'll get to the same spot. Do as many 360s as you want. You do have to put a rule on n. N can't be any number. Because if n was a decimal, then you wouldn't have done a full spin. So you have to define n. You define n as an element of the integers. Integers means positive or negative whole numbers. If it was negative, you're going backwards, right? If it's positive, you're going our regular direction, which is counterclockwise, which is backwards. Backwards of the normal, which is backwards. Pardon? I don't know, probably some Greek. I actually don't know. I don't know why they measure that direction. I don't know why they call it, like, to me, everything's clockwise. Like, clockwise would be the normal way to do things. It actually was probably like somebody in Greece or something, like a long time ago when math was being invented. They just went that way.
So instead of doing negative 360, you'd make n negative to go backwards.
Yeah. Or you could actually write this in another way. I've seen it before. They say take your angle theta, add or subtract 360 n times, and then they say n is an element of the whole number system, which would then tell you like, okay, you could subtract that number as well.
Is that like
This is the better one in my opinion, and the one you'll probably, if you ever see it, will probably see. But when it comes to your general solution, like this definition is important, right? Like if I said you could only spin forward, it would have to be this one. It would have to be a whole number. Cool.
Are negatives not whole numbers?
Negatives are not whole numbers. Negatives are integers that are whole numbers. Yeah. Integers are negative whole numbers. That's what I was going for.
Or positive whole numbers?
Yeah, like if you remember your number system, it started with natural numbers, which was 1, 2, 3, 4 counting numbers. And then whole numbers was natural numbers, so counting, plus the number 0. And then integers is when they introduce negatives. So that's when it goes backwards. Cool. Negative angles we've actually already talked about. The biggest one, which we have not discussed, is called a reference angle. Remember when we were building our unit circle and I said you have special triangles, like you have that 30-degree triangle all over the place in every quadrant. That was me referring to the reference angle of those terminal arms. The reference angle always goes from terminal arm, I'm just going to say from arm, to closest x-axis. And it must go to the x-axis. We will not build triangles to the y-axis. We will build it to the x-axis. Unless you get a crazy question where they put it in the y-axis on their own. But for us, reference angles, x-axis. That means for this terminal arm, my reference angle is right here. That's my reference angle. For the record, and I do like to make sure like this is known, since I'm always going to my closest x-axis, reference angle should always be less than 90. If it's bigger than 90 degrees, you didn't go to the closest x-axis and you are not a reference angle.
It is 90.
You could have a reference angle be 90 degrees. That's fair. So less than or equal to 90 degrees. So if you were on an axis, you could have a reference angle of 90. But then that's a wild situation.
Would it be like, does it really matter what x-axis?
Yeah, because you got to imagine then that you have a triangle with two sides of 0, right? Or two other angles of 0. It'd be 0, 0, and 90, which is kind of like a conceptual nightmare. Yeah.
So then for like triangles with a 90-degree angle, that's just like reference angle, standard position are like the same.
No, sorry,
Oh,
no. Because your standard position could get you to quadrant like 4, right? Like your standard position is always here all the way around. So if I did my standard position here, this would have a reference angle of 90, but it'd be a standard position of 270.
Oh.
Because it's from here all the way around. Yeah. Mm-hmm.
What if like, okay, what if it's like a right triangle? Like a right angle? Like what if the other angle is 90? Like standard position is 90. What would the reference angle be?
90.
Less than 90.
It'd be 90.
Oh, it can be 90.
The standard position and the reference angle can be the same thing.
Okay,
So if it doesn't go beyond quadrant 1,
less than or equal to 90.
yes.
Okay.
Okay, we're going to sketch some of these, and we're going to talk about terminal angles, coterminal angles, all that jazz. Let's sketch 2 pi over 3. Okay, so sketching 2 pi over 3. That is on the unit circle. We're going to not even worry about it being on the unit circle, though. Oh, the computer's about had enough. Okay, bye, video. Who's not here today?